Hello, hello, hello. I think we are live. Now, I am trying to add a feature, like a new feature, to the stream. I want to show the comments, live comments, all right, on the stream. So let me give me a couple of minutes until I'm completing those parts, and then we'll continue with leetcode. All right. While it is doing its job, we can let me first check the sound. I think that is all right. So now today we are like a not bubble sort, because maybe bubble sort too, but I want to focus on heap and creating an animation for that on Blender. Let's see what we have here. Yesterday we have studied heap sort and quick sort. Now today let me close these sessions because I don't remember anything. So let's start with heap. I wanna study heap. I know that heap has, bubble it down and bubble it up functions. The last sorting algorithm that we have studied is was heap sort actually, and like I really enjoy studying it because it has because I love visuals, and we have its video, its animation, and also like learning the sift down method. It was good actually. Uh, um, now I wanna study heap. I wanna learn the heap data structure, its methods, and also there is a woman who is proficient about algorithms, and she organizes some interviews in Google, I think. I forgot her name, but on YouTube she was explaining heap very well. Can you find it, and can we follow her code? And we can divide her code, and then we pick like a not wrappers part, but the essential. We can start with the atomic and essential part of heap, and then after learning the core, we can complete whole algorithm and data structure. What do you say? Now on the another screen. Oh no, like I paste the dictation in wrong place. Let me find it. This is the correct one. Copy and paste here. Like I forgot her name, but luckily the cloud will understand. Like she is well known, let's say teacher, I think. She has like a lot of books she has written. One of them is for specifically for preparing for interviews. I guess her name is something like Gary. Female Google engineer, YouTube mock interviews algorithms. Like Cloud will find her for sure. We are live. Let me check the internet connection as well. Hold on a second. I will back in a minute, alright? Now we are back again. Sorry guys, I had to handle something. So where were we? So yes, Gail Lickman McDowell, wonderful, wonderful, wonderful. So we should remember her name. Let's say interview. All right, save it here. Author of Cracking the Coding Editor. Like this book is amazing. All right, so AI also found even the link of the heap video I have mentioned earlier. Uh, for atom wrappers, yes. Like as we completed in heap sort, we also have sift down here in heap as well. Um, I guess maybe it is a good idea to first create its animation. Actually, can we create its animation using Blender MCP? But before that, show me what you're gonna build, because we should divide. I mean, you created layers like a layer 0, layer 1, layer 2. Like this is what I've been looking for actually, like a layer 3. Amazing. Like I already know sift down. Maybe we can start with sift up, and after having its MP4 like a rendered version, we can continue with layer 2, I guess, right? And also, can you create a markdown document about heap in one of our folders? I'm looking for correct folder, but maybe we can find one. Like where should we place the heap? I think we have heap here. Like a standalone. Wonderful. I guess we have. Oh, wonderful. I guess we have a heap here. Analyze it, and maybe we can continue with the remaining parts. Oh my god, I have broken the UI. Let's press enter and let's watch the videos. Which language for the heap? Should we try with Python or Java? What do you say, guys? Let's continue with Java, I think. Like this is bubbling it up. So like recursively, as we swap, we check the heap property, all right? And then if it is not, we continue. What is this video? It is the same, I think. Like they're all same. They're all same. Now I have a clear picture. Here's the current state of leetcode heap. What is heap intro animation? It says like I don't. I guess I should open these videos like this. Let me open them using QuickTime Player. Here we go. All right, now like we have an array, I think. 1, 3, 2. Yes, so 1, 3, 2, 5, 9, 8, 7. 5, 9 is all right. Like array representation of these three. Wonderful. Wonderful. We swap. I guess what we had is not a heap. Like, is it a max heap or min heap? Like, I guess the last item we inserted here is 0. Mm, and we have min heap. So we check the property of min heap, which like a parent should be smaller than its children, and it is not. So we swap that children with its parent. So I guess it is a good time to review the heap sort that we have studied yesterday. All right. So what do we have here? Like we have 9 as a root and 1 2 as a children, and we have min heap, so we should change, like we should swap. But which one? Like in max heap, we were um, swapping, like we were selecting the larger one. Now we are doing the reverse, so that we are picking the smaller one. And for swapping, we pick the smaller one, right? Please, yes, say yes and yes. We pick the smaller one, so it is opposite of max heap. But the thing I don't remember fully is that were we doing like this is bubbling it up, but in heap sort, what we were doing is like extracting the head and then taking the last element from leaf nodes and moving it there, and then we again apply heap sort rules and we swap, and like we make the new root sing. Actually, let me open its animation too. All right, hold on a second, let me read it. Let me read this part first. Wonderful. Because in heap we have bubble it up and bubble it down 2 ways, but I guess in heap sort we didn't have, bubble it up. The live Blender viewport is showing the heap sort extract phase, not the heap fundamentals. So running Blender instance may have a different file open. Yes, exactly. Confirmed. And good thing I checked the file of yes, it is yes. So the running instance has your heap sort extract scene open. Now let me write the markdown doc you asked for. It captures the layered decomposition, man. Like decomposition. Like this is a good word. And where can I type it down? Like, hold on a sec, guys. I will be back in a second. I guess my cargo has come. I am back, so it is not my cargo but my sister. Um, let me find the correct file so that we can take some notes over here while studying. So let me type it down, because the composition and wrappers versus atomic essential, like these are important stuff, all right? Because while we are trying to explain to AI our goal, these terms helps us. Let me fill my water a little bit. because it is hot. Let me increase the volume of the background sound a little bit. It seems just fine. So leetcode heap docs. Alright, so it created a documentation. Like it says already exists from previous sessions, so layer 1 was at least partially animated for. I haven't watched it. There is already heaps of so this is what it means. So I guess this is shift up. So what we do basically checking the like a child with its parent. But I remember we had something similar in heap sort too. I'm thinking about the way, like the direction. The direction. Whether we compare parent with its children or children with their parents. I will check it out. Like this is important. There's already some. How should we handle layer 1? Alright, like it can treat version 1 as done. Do you also want to write the Java heap class while we animate? Actually, let's continue with animation because I want to see it first. So now, while it's building that, like this is the extract phase, I suppose we have like we have a sorting here and heap sort, and in heap sort we should have our videos, I suppose, but I guess like did we save it? All right, I guess we haven't, like because yesterday we had building phase and extracting phase and I don't see any video with like a building. Yes, here, wonderful, in renders, build and extract. Yes, we have, like, all right, we have their versions. Wonderful. The open heap sort file has unsigned change. What should I do before opening? Save heap sort, then open heap. Yes. While it is doing that, let me handle the Twitch stream. So I was creating some daemons for some process. 2 corrections I owe you. Maybe after, oh, like the messages are shown in the stream, so I can continue with like a remaining part after the stream. That's just fine. So we can continue. Heap sort saved. Heap scene open. Now let me map this scene's structure. All right. Now we have started studying heap. All right. All right. Wonderful. Rich scene. There are 2 heaps here. Now I fully understand the file. Which file you are talking about? Let's see which file. I guess it is created. So actually it would be better, like great, if we note down the layered it has shown, yes, these layers, so copy that one, open, let's open another class session, but like I cannot copy from there. Maybe I should open another class session, or let's try it. Maybe in heap, like we already created a document, like heap data structure. I guess here we have the layers, right? Maybe I can make it a little bit smaller, but yes, the composition, yes. So layer 0 is like, this is the essential part for our heap data structure and heap sort too. All right. Studying heap data structure. All right. Like as I change the size, like size of the cloud session, it fails at placing its components, but that's all right. What we have here is heap basically, and let me check what we have studied yesterday for heap sort first. So we have build phase. All right, can I open this like is there open with option here? Yes, I think. What will happen if I click on this? Configure default editor for MP4. Yes, please. I guess we don't have this. It would be great if we, like it gives me two options here. Anyway, let me reveal in Finder and open it with QuickTime Player. So like this is the build phase of heap sort. So like this n divided by 2 thing says us don't process the leaf nodes, but start from the rightmost part at the level above the leaf nodes. So we start from here and then we check, like we check its value with its parent, or like here, like it is shift down method. So we compare this with its children. All right, so like this is what I was trying to remember. All right, because here in, let's say, heap fundamentals, like this is heap fundamentals, and like what we do here, like a checking a node, like checking the node's value with its parent. So this is like this, like we didn't have this in heap sort. All right, we didn't have this in heap sort. So let me check the stream again one more time to make sure everything is just fine. All right, I guess you can hear me. Other than that, yes, so we didn't have this kind of thing in heap sort. All right, because what we do instead is comparing the current node with its children, and then like what we do is like a shift down. All right, we don't have like a shift up here in heap sort, at least in like anywhere. In heap sort, all we have is like a sift down. Like this is sift down, and let me open the extracting phase. Yes, this is extract. So again, what we have here is swap and sift down. All right. And where do we start? We are starting from the end. So I think we are starting from here, but it doesn't have any children. So what is the point? Let's see. Oh, we swap. Like we are doing another thing here. Like we are doing extraction. All right. We don't compare the like actually we will, right? We will do it, but first we swap the last node with the root node, and then what we do, like, and then let's see, like, are we comparing the parent and the child? Let's see. So we swap the root with the last element, and then we do this. So like using 0. So we compare new root, I guess. Like new root, we are validating if the root is valid for heap property. So by calling this, I think we change this, and again it is not valid, so 2 should go here, and since this method is recursive, it will do it, I think. Yes. Wonderful. Wonderful, 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 wonderful. So this is something, guys. This is something. This is something. All right. So let me open my notes as well. Let me move it here. So basically in heap sort, like we have sift down, like this is the essential part, like this is something everyone knows, and sift down, like for sift down method to work, we give a node to that function, and this method compares its validity, heap validity. Like basically it makes the node sync. All right, wonderful, syncing. Like we have this in heap sort too, but what we see here is not syncing but promoting. This is a min heap, and each time in each iteration we check its validity on heap, like heap validity. Like this is bubbling it up. I guess we, like, I need to see, like we need to see the bubbling up code. So here what we do, I guess we, like, now we are applying sift down method here. Like we gave this node to our sift down method, and it checks, like this is sift down. All right, like this is sift down, this is sift down. This is sift down. Sift down in heap data structure, because we compare the value of this node with its children and take the min, like choose the path of the minimum one and go in that direction and swap. All right. All right. but the first part is bubbling up. This is something else. Like we don't have this. I suppose we don't have this in uh, heap sort, right? Like we have extract phase and build phase in heap sort. While building the heap, like we need to remember these details, guys. While building, for example, you don't like you should know where to start. You don't start from here. You start from here, and then you apply sift down. So like so there are two different places where you can apply this sift down method. All right, one is like you can give the root, all right, to our sift down method. Like this is one option, or another option is giving any node basically. All right, let's say like these are leaf nodes, and like in heap sort you give this node to sift down method. What it does is exactly the same. All right, it checks the value with its children and see if it is valid heap or not. All right, so in extract phase is again we are using sift down method, but we swap the root, like we basically extract the root here. All right, but by extracting we mean swapping it with the last node and decreasing, like shrunk the heap. So we don't process the last node anymore, like a never. So we swap, all right, and we forget about this, and then we apply sift down method to this node. So this is only thing that we need to know, like we need to remember. All right, like forget about the remaining animations, like this swapping and this swapping, like forget, like this is recursive, and only thing you do is like calling this function on this root, like on this node. All right, and then what we are gonna do is like again we're gonna swap root with the last node. All right, we're gonna swap these nodes and then apply sift down on the new root, like so. Wonderful, 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 wonderful. So I feel ready to write this heap sort by hand. All right, wonderful. So what we were doing is we were studying like a heap now because like I wanna complete this question, like, and then the bubble sort, like bubble sort is easy, and then we have happy number. I don't know which topic is this, but I guess it is frequently asked question during interviews. And then we have some matrix question, and then threesome, 2-pointer question, sorting. All right, so these are the next questions we're gonna study. So I guess I can copy the video here and paste it here because I love animations. So let me copy the video here and paste it. So this is build phase and this is extract phase. All right, so maybe we can take a screenshot of this part and paste it. Like this is my note application that I use for mostly leetcode and some technical stuff, because it allows me to take notes like with using images and audios. There are two locations we call shift down method. First is root, and the second one is any node basically. So you determine it's you determine the place you're by yourself. Like in this case, we are building heap, so we don't process the leaf nodes, but instead we start from the rightmost node in the level on top of the leaf level. All right. So like layer 0 is shift down. So like this, like a shift down is crucial. Like let me even type in our label shift down. All right. Layer 1, we also have, like it says that we have shift up method as well. I think in heap folder, yes, like shift up is easy too. Yesterday while I was studying, I thought like today it happened today too. Like let me take a screenshot and show you guys. Like I thought that were we comparing the values, all right, let's see, our node is this, were we comparing the values of like checking the validity of heap, okay, comparing the node with its children, or let's say we have this node and comparing its validity based on its parent. All right, like, but the correct answer is you call this node using shift down. So you basically compare its validity using its children, but we have also, you know, comparing it with parent situation here, but that situation is for up. Let's call it bubble up. So we have this method too. So here we get like we call like a bubble up method with, let's say, node 5, all right, and then what it does is comparing its value with its parent. All right, so we have shift down and bubble it up. Next, and then insert. Oh. All right, so all right. So let me take a screenshot. I think we have heap data structure markdown document here. So we completed layer 0 and layer 1, like a shift up and shift down, wonderful. And then wrappers. So insert extract max shift down 0. All right, so I guess we need to now study these, and we're gonna build an animation for that, like animation for layer 2, I guess. Now, like next up is extract max, the mirror of insert, remove root, move the line, like move the last element up to the root, then shift down. Like we have, yeah, we have this move in heap sort 2. We extract the max, put it somewhere, like to put it the last position in our heap, put it somewhere, and like before that we swap, actually, right? We swap. No, we extract, we get and put it here, but before that, are we like do we swapping or not? So let me check. Actually, we can find it using like in our animation. First swap, but if we swap, then our max is not like the correct one. Like this is why I wasn't sure. So we swap, yes, and get 9. So what makes this move? Like we get 9 and put it here, but at first we swapped these two elements, like a 9 with 2, like this is swap, and after swap we apply shift down to actually like a new root, like we are applying. All right, like this is, I think this is a part I didn't understand, because we get this 9 and put it somewhere, and this is like this is extract max. All right, maybe we can ask this. The mirror of insert, remove the root, move the last element. Yes, so we basically like remove the root, move the last element up to the root. So while it is describing this to us, it says remove the root, move the last element, but here we swap. All right, so there is a transition, like a translation maybe. So here we swap first and then shift down, but what happens now we don't know at all. We don't know nothing at all. But here it says like this is the correct one obviously, but when we translate this definition into code, there are some parts that change. Move the last element, yes, up to root, then shift down, yes, that element, the atom you already, yes. It is the most satisfying one to animate. Max gets beheaded, yes, and a small value sinks back, yes. All right, so where is, yes, let me move it here. The composition representative, so I guess I can type layers 2, like a layer 2. Here what we have, extract root and shift down new root. I guess take the last element and put it to root position, and then shift down new root. All right, like this is extracting. Wonderful. And in layer 2, what else we have? Like insert. Control Z, I guess. We have insert, append at end, shift up plus. So I guess we can create an animation for insert. Want me to go straight into building extract max? Actually, we don't need it because we already have it. Like we have. I guess it would be great if we have extract animation for our heap, because here, we do swapping, but what makes 9 to go here, we don't know. All right, like this is a process. Yes, all right. So you can start with creating animation for extract max, and then we can continue with insert part. Actually, we have like something in our Blender. Actually, did it create it? Let me ask it. Hold on a sec. By the way, did you create, have you created the animation for heap insert? If so, where did you? But I guess you created animation, right? So I guess we can continue with extract max. So I guess it already created. I didn't see it, but let me delete these parts. So this is insert. So let's see how insert works. Like we are inserting at the end of our heap, basically. All right. And then we are gonna, I think, we're gonna bubble it up, right? Yes. We are bubbling it up. We are bubbling it up. Let us watch. We add it at the end, and then we check heap. What is this? Like this is wrong, but that's all right. So that ring should on top of the current process element, but that's all right. Um, Maybe we should like we can fix it. So amazing, you created heap insert animation too. Amazing, but the ring, like a position of ring, is not correct. It flies around, but this is not correct. So fix it first. Save the file. Create our MP4, and then start creating extract max animation, please. Actually, like, is this a new file? Let me check. Or we already no, yes, this is a new file. So press enter, open my notes, and then our next is bubble sort. Actually, let's not study this, all right? But we can watch its animation, all right? Animation helps so that we review. So we have renders here. This is bubble sort. Basically, we have like a link of two platform, and it compares these two values at these indices, and then swap them if the right one is smaller than the left one. So and then we move forward this platform and then check again. All right, let's watch it. So the platform is there. We swap the elements. If the right element is smaller, wonderful. And then we're gonna start again, right? Yes. I guess yesterday we have studied something like something like that, but I think it was quick sort, right? Let's see the quick sort animation as well, because I remember we had something like, I don't know, again we had some sort of platform, but I guess it is not quick sort either. But I don't remember we studied bubble sort yesterday. So what was that platform that I remember? It is not merge sort, obviously, not heap sort. I don't know. Maybe we studied, but I don't remember, or I remember the wrong time. Let's see what it says. All right, so it handles. So while it is handling that, like, I should update this code because it opens each time, but that's fine. I think we can continue with happy number. So let me open my AI session here. Activate tutor mode 2, and we're gonna study this question, and make sure you create its folders in correct folder. I guess it is a greedy problem, right? So if it's a greedy, create its folder under greedy, or if it's not, create corresponding topic for this. All right, so I have a skill for studying, actually, that makes Claude to behave as a teacher rather than bump, or not like a dumping code right away. So in this session it is creating our animation for inserting, I think. But I think we know insert, not inserting, but extracting phase of heap. And in this session we're gonna study that one. I guess we can update our label saying, let's say, how many leetcode problems do you like to solve today, guys? Like, I completed the first 24. I'm quite familiar with the first 24. Now I should finish this part. So let's make it 10, right? And let's count heap sort. Like we almost complete heap sort. Maybe we can study its time complexity. Like we can ask its time complexity and note it down. And then we can continue with this one. All right, so I want to call 1 out of 10. Now it is time for happy number. Problems and currently happy number. Save it. Check the stream. All right, now I guess we can ask for actually let me create another one. Can you tell me the time complexity of insert, like an insert operation in heap, and then extracting, like extracting from like a root, like a inserting and extracting, I guess. Like which time complexity, like which processes I should know in terms of time complexity in heap data structure. We should know the time complexity of these operations. So yes, so tutor mode 2. Before we start, actually I don't know anything. For context, the problem a number is happy if repeatedly replacing it with the sum of the squares of its digits eventually reaches 1. If it loops forever without reaching 1, it's not happy. Can you give me an example? Like the number is happy if repeatedly replacing it with sum of the squares of its digits. So square of its digits. So it is 19 and we replace it by using 1 plus 81 and 81 with 68 with 100 and 100 gives 1. So like it seems quite it seems a while loop. And in each iteration we don't know how many digits we have, so we should have a structure that will process each digits. Maybe the part for this question is like, without knowing the total number of digits, how would you design? For each number we should first get the number of digits and then apply that process, I think. But what if we never hit 1? What would happen then? It hit 4 again. I see. Like this is a hint. Like I don't know if the leetcode gives us, but let me open it. Let me leetcode happy number, and let's see how the question given, because I don't think they gave this. Repeat the process until the number equals 1, or it loops endlessly in a cycle which doesn't include 1. So those numbers for which this process ends in 1 are happy. So two is not happy because a 2 is not happy. So you take square of it, so it is 4. You take square of 4 and it is 16. 4, it is 16, and you take 16 and it is 37. You get 37 and 9 56, I guess, and 56. I think it is not, but 25 64 9 8, I don't know, let me check. 5 yes, and this one 81. 64 and 81, 5, 6, 8, 14, I guess, right? Or this can be 5 too. 64, 81. No. All right, this is correct. And 1 plus 16 and 25. 16 and 25 is 41, 42, I guess. So I guess like in the question in leetcode, they didn't give this hint, because like I thought that what would happen if, like, what is the definition of cycling here, or like I didn't think of the concept of cycling in this question, because but I thought, what if we could go endlessly? But this says at some point you go into a cycle. We've seen 4 before, so like this is the hint. Actually, it would be great if it didn't give this hint, because like this is the part of solution, all right? Because you should come up with this sort of ideas during the question. Because let me say, so thank you, but I think you failed at using this tutor skill, because you gave a hint that shows like we start with 2, and during the process we hit 4 again at some point. But when I first see this question, the only thing I ask is, what if I could we go endlessly, all right? Because I didn't know we can hit the same number at all. Like I didn't think of this at all. I guess it is quite important for solving this question, all right? But you dump it right away. Why did you do that? Why did you do that? Because it is a crucial step towards solving this question, right? Because in the question definition, we don't have such a thing. A happy number is a number defined by the following process. String with a positive integer, replace the number by the sum of yes, repeat the process until the number is equal to yes. So yes, so it doesn't say like we don't have hint 2. Let's see. You're right, I believe it. Yes, you believe it, man. You asked for an example, and I gave you the work trace of n equals 2. Like actually in the question itself it gives 2 as an example. So like we should continue, all right? We should continue a little bit more. 42, and we're gonna see by ourselves, all right? We're gonna see it by ourselves. So 16 for I guess 20, and 20 is again 4, and now we should realize that we already have 4. I mean, like this is the first step. So like from this point forward, we're gonna have, we're gonna have same thing over and over again. So I guess 37. Yes, we have 30. Yes, we have all. Of course, we have 37. So 9, 49, 5, 6. Yes. So and the list goes on. All right. So like at least like they didn't give explicit, like they didn't give the hint explicitly, but in the example 2, if you try this, but you should try this, all right? Because by looking at the question you cannot come up with some ideas. You should try this and see it yourself, like because there are some questions that you need to, try some cases and come up with an idea based on those tries. All right, this is one of them. And now, like, what should we do? Like, but again, like, even you see that this has repeated, but do we have any proof that for any number given, let's say 12, we hit cycle again at somewhere along the way, like along the way of this process? Like, do we have proof of that? Now I can ask this question, like, do we have proof of that? That's me handing you the entire inside of the problem, the whole discovery you were supposed to make yourself. Wait, can this go forever? Oh, it repeats. Yes. I just printed it on the page. Yes. Why I did? You asked for an example and I put it out to two examples. Wonderful. And I picked the second one specifically because it loops. Yes. Then annotated the loop. That's the anti-pattern. The skill warns about writing the answer and you annotating it. I should have given you one example that only shows the mechanic. Square the digits, yes. Test operation. Now you tell me. When you look at this, what's the question you have? You already named it. What if it goes endlessly? So sit with that. What would have to be true about the sequence for it to go on forever? Like, it should be true that for every number that we get from, summing the squares of digits up, they should be different and not hit 1. I guess the answer for your question is every number that we get from summing the square of digits up, they should be different than each other. Because if we find the same one even once, then that means, we cycle. But we don't have a proof of this. I mean, by applying this logic, we could have a different number in each iteration. So there is no proof of that. So how can we prove that? Yes. So this is the first question, and then while it's answering that, maybe we can think of like if I'm sorry for that. I mean, if at some point we see the repeating character, the repeating number, let's accept this. All right. Let's don't spend lots of time, but accept this fact and try creating the code. So what we need to do is, while it is not 1 or we don't have repeating outcome, maybe, like if we don't hit 1 and all the numbers we collected so far are different, all right, we loop endlessly. So for that, maybe we can have a map or something, hash map or something, I don't know. Maybe we can store like we get the square of digits, all right, and maybe we can add this result into our map, and maybe we can make use of set, because while adding an element to a set, if it has that set returns -1 as far as I know. So adding like a that result, and maybe we can add an if condition here, and if it is false, or I don't know, maybe -1. If it is, maybe like, does it return -1 or false? Let's call -1 because somehow I remember that way. So if it return -1, Then we have repeating cycle, like we have repeating, so we have cycle. So cycle detected, and if we detect cycle, we should break the loop or return false right away. If we detect a cycle, return false, and otherwise, and if it's not one, if it is, we can go outside of the loop, or let's make it true. All right, like this is risky, but let's make the loop true, and if we detect cycle, we return true, and if we actually, like, making this is dangerous, I don't know, if we don't detect cycle but we detect like if the result is 1, then we again should return what, like return true this time. And if we have a proof of, like, at some point we're gonna see repeating number, let's say, like here we have 2 as a starting point, and we get the square of its digits up until the point where we hit 4 again. So I guess we can generalize this, that for each number we're gonna hit cycle at some point. I don't know why, I don't have the proof, like no proof. All right, no proof, I don't have the proof, but I guess we have somewhere. So if we have this for each number, then this code will work, I think. Let's see. That's a genuinely senior question you spotted. I mean, spotted is a good word. So while studying some LeetCode, let me spot and capture. Like, I'm studying English too. So yes, let's continue. This genuinely senior question you spotted its cycles is an assumption. Yes, it is an assumption. We don't have proof of that. Like, not a proven fact. Most people never question it. Good, thank you. Your worry is, what if every iteration just keeps producing a brand new number? Exactly, brand new number, forever, and never repeating. Yes, it can be. For that to happen, the sequence would need an infinite supply of distinct values to draw from. Yes. So let me hand you the one question that cracks it. Take a giant input, say 10-digit number, yes. 10 nines, about as square heavy, yes, as it gets for 10 digits. Run one step, sum the squares of its digits. Yes, so what is the result? Oh, no. Like, what does that tell you about whether these numbers can keep growing toward infinity? So let's see. Let's put 10 nines. 10 nines. If you get square of each of it, so this one, and 2, I mean 9 to the 2, right? What we end up with, like a summation of 10, 81. What we get is like a quite smaller compared to the number we have. Yes, but it doesn't prove anything for me, at least. So what we got, like, we got this, but this doesn't prove anything to me, at least. I mean, It is a relatively small number compared to the number itself, but does it tell us that we can, like, we can't go forward, like we can keep growing infinitely? So, like, we should see. Like, for me, for my eyes, it doesn't prove. Like, still, it doesn't prove that we're gonna hit the same number again along the way. You are circling the exact right dab, dot, dab. One example, collapsing. Collapsing. Another good word. Collapsing. Doesn't prove all big numbers collapse. So let's kill the dab generally, not by example. Look at the gap between digit count and the value. A 4-digit number is at least yes, but the most digit squares can sum to is yes. So every 4-digit number, no matter which one, lands at you. So now your turn. So what it says basically, if you have 4-digit number, say 1,000, and the max value you can get for 4 digits is this one, and this gives you 2, like 3 to 4, I guess, right? Yes. And the less, like the smallest number you can get is 1. So all the numbers between these two 4-digit numbers is between 1 and 324. And like, how many numbers we have here? 9,000, like a 9999, 9,999. We have this amount of numbers, and if they keep cycling, let's say through like a let's say among these numbers, between 1 and 324, then we are sure that there are some cases that hits same again. Wonderful. So now I believe you. Like, I believe you, but so any number we get as an input between these numbers, definitely they're gonna hit same, summation of squares up, right? Any number between these, like any input between these numbers, definitely hit. So I guess we can generalize this. All right, so now I get. All right, I believe you. Thank you. I believe you. Thank you. And my code that I wrote, like we wrote, is a while loop, and its condition is true. And inside it we have we have two if statements, and we add the result that we calculate, like a summation of squaring the digits up. We try to add this result to the set we have, and if it returns -1, I guess this is what it returns when it encounter a same number in itself. If it is equal to -1, we return false. All right, like this is the first if condition. Like the second one is if the result itself is equal to 1, then we return true right away. And that's the whole code, I suppose. First write my code and then verify. So let's see if we got it right, guys. Let's see if we got it right. So if you have any questions, you can ask, by the way. Actually, maybe while it is explaining this, I can update this part. Currently, I am live on Twitch, and this is what what is written when someone enters my room. Um, what I wonder is, can we change and can we make it such that kinesin ships work on leetcode right now, um, solving 10 questions in this stream? Can we update it right now? Is it possible without breaking the stream? So now I asked my another AI session to fix the welcoming message right now. Continue. Your shape is like, what is this? Your shape is sound. Wonderful. So like, this is something I see, not frequently. Yes. Your shape is sound. While to complete the digit square sum, yes. See it before, yes. That's the classic Hess cycle detection solution, yes. Get this version working first, wonderful. Floyd's two-pointer is the optimization we can do after your usual move, unoptimized first. I guess I remember a question. I think it was. I guess after solving these questions, we can study brute force, all right? Because during interviews, you start with brute forcing, and then you start implementing by using like a two-pointer, sliding window, and maybe some recursion, I don't know, and some like a backtracking. Backtracking is just a recursion with optimization, like a space optimization, as far as I know. Yes, so my goal here is now like finishing, like completing these problems. All right. So Floyd algorithm is just an optimization. So maybe we can type it down. Floyd is just an optimization. Wonderful. Maybe we can color this optimization with yellow because yellow looks great here. Save it. And for heap, I think we got the answer from here about the time complexities. No, like time complexities were here. Yes. Wow. Peak is 01. Yes, because you can find the maximum or minimum based on the type of the heap by looking at the root itself. Insert amount is log n because as you insert an element, you as you insert an element into a heap, all right? Maybe I should draw a tree and copy that tree during our stream, right? So we have this tree. So when you insert something to it, what you do is verifying its heap property, let's say, and then bubble it up, all right, basically. So let's say at this endpoint you add this node, all right, and you should bubble it up, so by comparing its value with its parent, all right. And then if it doesn't validate, if it is not a valid condition, you swap it, and again and again and again. So this is basically bubble it up. Wonderful. And the cost of this is the number of levels. So what is the number of levels? It is log base 2 n, right? And we transform it to log n, right, guys? Wonderful. So extract root. So while extracting the root, let me copy that. So let me copy that part too, paste it over here. While extracting, you extract the root. We had the root, and you swap the last node here over here. So let me, oh, like, it would be great if, yes, we had the root. All right, we swap it using the last node we have, and then this is important, the important part comes, and then we bubble it down, like, which is not shifting but shifting. Like, do I pronounce it correctly? I don't know. Like, it resembles shift quite much, but it is shift down. So we do shift down operation to this node, which is basically comparing its value with its children, verifying the heap property, and based on that promoting one of its children, and then syncing that node. Wonderful, wonderful, wonderful. So 18 minutes left, so let me handle the thing I have for the stream. Maybe I can show it to you guys too. I can't post on your Twitch. So no restart path is you typing that line. The alternative me adding, like, I don't need to type it, but maybe I should look at it here, guys. I don't know. Maybe any confidential file here. Let me check. All right. Maybe I should update. Now handling OBS. Then we'll continue from. All right. Yes, the safest way needs to restart and won't touch the stream at all. So the daemon raise the topic live from memory. Yes. So you just need to change the topic, paste this one line into your own Twitch chat. You are the broadcaster. Ah, sorry. I can do it by typing this topic. Yes. All right. Wonderful. Wonderful. I forgot about this topic command. Wonderful. Thank you. Can you create a memory for this so that next time maybe you can find it faster? I have run that command and this is what I've been looking for. Thank you for that. Paste it here. Maybe we can update the title. Some leetcode learning Python during breaks. That seems fine for me. Basically, guys, everything is login, alright? Like building heap, maybe this is important. It is on. Like important part is like this maybe, because like building the heap is quite importante. Open the heap. Now paste this one. Maybe I can paste these ones too, like an operation, like a peak. insert extract root. Maybe I can type them line by line. Sift up, which is like a all again, like I totally get it. I hope you will understand it too, guys. Sift down, yes, sift up and sift down. Wonderful, 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 wonderful. And build heap. Decrease key, yeah. A heap is not a search tree, so no ordering between siblings. You should look up every element to find what you are looking for. So this is something important. So I can take a screenshot, click on save, and paste it here. So now we are studying happy number. We were studying happy number here. Let's continue. So my approach was using a while loop and using a set, using a while loop and two if conditions. We were handling this. So where is my code, basically? I believe you. Thank you. And your shape is some. Yeah, we were here. While true, compute the digits to some. Yes, some. Two exits. Yes. One thing I'm parking, not correcting it yet. That returns -1 digit. Hold that thought. We'll look hard at it when you read your code. Go ahead and write. So I don't know, guys. Maybe I should just type it. Like I hate typing, but I guess there is no escape from there, right? So let's delete it and let's type it down, guys. So we have we need to have public. Let's call it void. Make it void, and a method A. All right. And then what we need is like a basic while loop. That's wonderful. And let's make it true so that it will run endlessly. And we have two if statements, all right. And in the first one, what we were doing was we need a hash set. Like I don't know how to initialize a hash set. Like maybe this one, I don't know, like maybe just set, because maybe we have interface of sets. So set set x, maybe I don't know, maybe call it numbers. This doesn't look right to me. Set of integers, should I give it like this, like a set of integers, or I don't know, I don't remember. So let's continue. Let's say we have a set, and we need to calculate the square, like a integer result, all right? Or even better, let's create integer results here and assign 0, and here let's give let's calculate, we need to we need to get each digit. So but there can be multiple. Maybe we can open another while loop here too, like a while, I don't know, number is greater than 0, I don't know. We can get the get the first digit using this one, right? Integer digit let's make it equal to 0. We have we should add result, add digit, a square of digit to the result. So we should add like the first digit, right? First digit. I guess this gives you the first digit. We add it, and then we should shrunk shrunk the. I mean, not the result, but the number. We should shrunk number by 10 so that we make it, you know, one digit less. But like if it is a correct condition or not, I'm not sure. All right, but let's continue. So let's assume we have the result we need, like we add all the squares. So now we need to check if the result is not equal, but um, like we should have a set. So we should try adding like a numbers, like in adding that result to that set. um, we are adding the result to that hash set, and if it returns -1, I guess, I don't know, but we can check. If it turns one, then -1, then we should return false. So that makes our code not void, but uh, boolean. Wonderful, wonderful, wonderful. And in the second if condition, what I imagine, like what we imagined is like a not, I mean, like in one case it should like the cycle detection, like this is cycle detection, cycle detection. And the second case is not cycle detection, but what was it, guys? Like first one, let me update the label too. I guess it doesn't show the correct thing now. Let me remove that part. Happy number. So first thing was checking if we, let's say our number was 2 and we hit again. So there's cycle. So like what was the definition of the question, by the way? So like we don't have it. I guess. So let me check from the leetcode itself. All right, leetcode happy number, like hitting 1, right? Yes. Yes, yes. So if we hit 1 along the way, actually we didn't get the square sum here and update the number. Maybe like this is not result, but maybe number, we can call it number, and we get the digit, right? We are not summing these, but instead we should get the digit, and then we should get the square of it. Digit equals digit. Wonderful. After that we should sum that digit to our result, I think yes. So we should have something for result. Wonderful, wonderful, wonderful. We are adding the digit, like the square of digit, to the result we have. Edit. Wonderful, wonderful, wonderful. So we add all the digits and we take all the, like we take squares of all the digits and then sum them up here, and then we check if that result, like if we encounter this result again in this while loop, that means we won't be able to add one in like ever. And then the second condition is um, checking if the result is itself if the result is equal to one itself. All right, if it is, then we should return true. So like this is what I had in my mind, but we for sure optimize it, because the question, like in this leetcode problem, they say there is a, I mean, I guess there is a two-pointer solution for this problem. Like I don't know it, but let's first give this method to our AI to make it judge. So this is what what I have written. All right, judge it. So let's make AI to judge our code. I think we may have some errors. All right, and also let me move my propeller here. Like I don't trust that this part, because maybe there can be some negative numbers, right? We don't know it. Let's see. Let me read it with you. Yes, do it, please. The skeleton is right. Inner loop peels digits. Yes, we are peeling. The outer loop repeats. Two exit checks, but there is a corpora, of course. Like this is what I was afraid. And I want you to find it by tracing. Thank you for that. Instead of dumping the solution right away, it guides us. Run your outer loop twice in your head with a real start. Say number is 19. Let us do it. So it says that iterate twice in the outer loop. So let's say the number is 19, the number is bigger than 0, and then we take its first digit, which is 9, we take square of it and add it into our result. Wonderful. And then we divide the number by 10, so we have 1 now, and we get its first digit and then square of it and then add it, so it is 98. And then we divide 1 again once more, and the number is now 0, and we are out of this. And now we add, all right, and result is not 1, and we didn't encounter the cycle. So now we go the second iteration of outer while loop. Here number is 0. No, like number is not 0. Yes, number is 0. Result is I think we should put result here instead of number. Like we calculated the result. I think we need to use only one variable instead of 2. But we have the number, we get squares of its digits, and then we should make the number. That's all right. So after these iterations, we should make the number equal to results. Wonderful. We have like solved it. All right, copy and then paste it again. I think we have found, I think I have found, all right, what you mean, because we should update the number, because in the next iteration of outer for loop what we should what we should do is processing 82, because in the next iteration, in the second iteration outer for while loop, the number is should be 82. Wonderful, wonderful, wonderful. So press enter. So I want to understand this and then go to go studying set matrix 0. So I want to study this problem, but let's go slowly. Like not slowly, but this is how fast I can go. Like this is the fastest I can go. That is exactly it. The yes, 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 yes. So we update the number. Now trace just result. I guess we have we still have some problems in our code. Now trace just result through that same iteration. At the top of iteration 2, what value the result holding right now? Like a result was holding 82. I mean 82, and we assign that number to our number variable. Yeah, so what is the issue here? At the top of iteration 2, what value result holding right now? 82. Look at where you last set it. Did anything set it back? Did anything set it back down? Like, are we assigning number is like huh we didn't um reset the result. So I think we should reset the result. After assigning it to number, we also should reset the result, because for each number has its own summation of their squares, right? So let me copy the code that we have written. Let's copy, paste it here. So thank you. I guess I got your point, because each number should have its own summation of their squares of their digits. So we should reset the result after we have finished calculating the current number's value. So all right. I want to continue with Floyd's algorithm. But first we should complete this, guys. Orders right to number, we assigning result to number, grabs the value before, yes, wipes it, yes, like maybe we can, before it wipes it. Wonderful. Grabs the value, yes, and your reasoning is exactly correct, yes. Time to unpark the thing I told you to hold. But I forgot it already. This line, yes, because I suppose, I assumed that when you try to add a number that is already there in a set, like in the set, it returns -1. Question: in Java, when you call numbers add on a hash set, what type does it return, and what are its possible values? You are comparing it to -1. Where does -1 come from? Is that what add actually gives back? What do you think add returns? Predict before you check. Like while typing that part, I was thinking of either -1 or false. Since I don't know, I don't remember the documentation in my mind, I assumed it is -1. But I guess since you pushed back, I guess it is false, right? I mean it returns false, right? So guys, I think we should also know the return value of adding in headset, right? Let's read it. So right instinct, it returns a boolean. All right, so guys, so the headset method returns boolean, not the integer. So -1 can never be true. That branch will never. All right. But it returns false is only half the story. Wow. Why is that? Why is that? Why is that? Add returns a boolean that both ways. It returns true sometimes and false other times. That's the whole point of it. I mean, I expect that method to return false when we try to add the same thing twice, because since it's a headset, we shouldn't be able to add like a new occurrences of the same number. So pin down the two cases. You call numbers at 82, yes. 82 is not in the set yet, yes. It adds, returns true. I guess what it tries to tell us, guys, is that like when it returns false, like yes, so when we try to add some element that is already in our headset, add method returns false, and we get its reverse of it, I mean inverted. So yes, so I think this is what it means. I guess this is what you are trying to pin down or show. And what is the verb for like using this mark like ahead of numbers dot add? Like I guess we get opposite of this phrase, right? But what is the convention for that? So we are learning English while solving leetcode problem, guys. Wonderful, wonderful, wonderful. I am eager to understand the Floyd's algorithm, but now like I want to finish this first. Quick answer to your question is logical not operator. All right. Logical not operator. Logical not operator. And the operation that we do, what is it called? It flips. All right. That's another good word over here. Thank you, but what is the operation called? Like negation or something like that? Negating? Like I guess it seems that we still have something wrong. Like now look at what you just wrote. Yeah, we try to add the result, and if it's already there, this will return false. Oh, sorry, man. Sorry. Like there is no need to compare it. Like it is already a if condition, so we don't need to do that. It returns false. All right. Let's copy this. And also my new answer is this. Amazing. Floyd's algorithm. I guess Floyd's algorithm is 2 pointers. All right. Let's see. But like how we are gonna apply 2 pointers in this question? Yes, the operation is called negation. Yes, as we expected, guys. As we expected it, right? Expected. Yes, the operation is called negation or logical not. A complement. Yes. Complement and complement. There are two words that are close to each other. The verb is to negate. Negate. Exactly, the verb is negate, guys. You are negating the return of add. Yes, the transformation engine and cycle detection are both right now. Time to reread your own method against the problem. Look at the signature. Yes, like signature is another word that I wanna say. Signature, like a method signature, method signature, method signature. And that's the first line. Yes, yes, yes. The problem has you a number n to test. Where does that n? Oh, so I think we don't use that parameter at all, right? So we should have the parameter like this is input, and then maybe we can make the number equal to that parameter, and then now our code can work, I think. So like I made AI to analyze the code that I give it to it, and starting from some atomic and essential part, we first handle these parts, and then it goes into some wrapper or less important parts. All right, because otherwise it just say you did this wrong, you did that wrong, you did everything wrong. All right, but we need uh logic of what is it called, like teachers know that um I don't remember now, but I can look it up. So teachers there is some teaching concept that teachers applied for like use for their students, like I forget that term. Can you remind me that term? All right, now we're gonna focus on the like a syntax error that I am doing. Logic is complete and flows in engine transform cycle. Yes, yes, yes. So this is like we have a syntax error here. Will set even compile? No, I don't think so, because I know that it is wrong. Think about what kind of type Java generics are allowed to hold inside. As far as I know, like it can hold like a class name, like not a primitive, but like this one. Like I knew that, but somehow I didn't apply it there. Can you put a no? I can't. I just can't. Maybe we should study generics. All right, generics like a Java generics methods, and not Socratic. No, no, no. These are not pedagogic. I wanted to tell you pedagogically. So instead of teaching concepts in random order, there is a certain order so that the student can understand it better. Because to understand the concept, maybe you should know another concept. So there is a chain. So it is pedagogic, right? Like when I use this term, when I give this term to AI starts explaining stuff better, basically, like pedagogically. And yeah, Java generics methods, wonderful. Let's see. Right, that's sequencing, specifically prerequisite sequencing. Yes, the idea that concepts form a dependency. Yes, dependency chain. All right, so maybe I should save these words too, because I just like them. And dependency chain. All right, because there is an order for learning. You can just start from middle. Learning hierarchy, pedagogical sequencing or learning hierarchy is the one you are reaching for. Yes, maybe I should save these as well. Like these are learning methods. And pedagogical sequencing. Wonderful. Now back to the part line. No, generics needs a reference type. Wow, needs reference type. So I guess we can create a heading or something. Let's heading one. Let's call it Java and paste it there. Yes, like this set, like a generics, like a this is generic need, like a generics need a reference type. So the reference here, I think, mean objects, right? And I wonder what you mean by reference type, because I mean like arrays are objects, like a string class, like you can create an object from string class, you can create an object from integer class. So do you mean by reference type, do you mean an object which is on heap? Like we create objects in heap, right guys? So I think after this we will be done for this question before starting Floyd approach. Your intuition is correct. In Java, every type is one of two kinds. Primitive types, yes. Reference type. So I didn't know this convention. Everything else, like a classes, arrays, interfaces, enums, the variable holds a reference, like a pointer, lives on the heap. Yes. So yes, reference type, a type whose variable points to a heap of yes, 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 yes. Why generics demand it? Generics use type erasure at runtime. Hmm. I guess I've seen this before. Generics use type erasure at runtime. Like at runtime, this becomes plain set object, and the type parameter is treated as object. Object is a reference type. It can only point to a heap objects, never hold a row int. So the angle brackets refuse primitives. When you write this where the result is int, Java silently outboxes it. So this term is asked during interviews as well, like outboxing. That's the bridge. Quick contrast, since it helps you, yes. Primitive reference, yes. Int is an object. In C sharp, int is an object. I guess I can increase the width. I guess a little bit more. In C, we don't have any, like no generics, no objects, just row int. Roll your own. So your setting is right. Your full. Hmm. Um, but before that, like, why do we need this generic type at all? All right, why do we need that? I think it is for, like, during the early phase of Java, we had some issues, like some runtime errors or something, like the coders had this issue, and then they created this generic so that even in compile, I mean, like as far as I remember, even in compile time, they can see the type, like a type of the items that they, I mean, use in their collections, right? So this is the story behind generics, right? And also after that we can continue with Floyd's algorithm, all right? Because this is the whole point of this question. I guess it is an optimization using two pointers, right? Now, like we will, like we completed the first basic approach. Now we're gonna use Floyd's approach, like a happy number. Floyd's cycle on digit sum sequence. Because this was the point of this question. I guess afterwards we will be, completed our first, like the second question today. Your story is exactly right. Like, concurrently, here's the pain generics fixed. Like, here's the pain generics fixed. So, like before generics, like earlier first phase of Java, they had like they initialize an array list. Let's say they add hello and then 42, and then in somewhere in the code they do this casting, and they were getting class cast exception. Why? Because you can apply this um, to that, but not this. I think if you get the second element, like compiles fine, blows up at runtime. So like this fails at runtime because you cannot transform integer, I mean cast integer to string in Java. Like, but I should ask this too. Like this is a good example. Like this doesn't give you a compiler error, but a runtime error. But I should ask this. Thank you for this example. Like this is a great example, but can't Java transform an integer to a string by casting? I think it is easy. Like it is easy operation. So why on earth it gets like it blows up at runtime? Let me ask it this, and then save blowing up, blowing up, and then the another word was mess up. Let's see. Great question. You hit a real Java. This one, the trap. The type syntax means two completely different things depending on whether it's a primitive or reference type. Real conversation. I mean, casting. I mean, converts nothing. It's just a promise to the compiler. It doesn't convert anything. Like an integer value of 42, a real integer object on the heap, not a conversion. I thought we were doing some conversion using this casting, but it is not a conversion, I think. Stringo does not reformat the integer into text. It's you telling the compiler, trust me, bro. Trust me, bro. The object O points to, like the object O points to is really a string. I guess trusting in this era is, in this world is not something you should do. Even if you are a compiler. Even if you are a compiler, you shouldn't trust what the coder says to you, I think. But like I learned this, all right, because I thought this casting is just converting. I think it has something to do with inheritance. That's interesting. Like you can cast the some, let's say, child class, like a child class to its parent class, right? So it looks at the actual object on the heap. That's fine. If you genuinely want the text 42, like a text, that's a different. Yes, like I had this in my mind. I think what we do instead of casting for that purpose, like making integer 42 a string 42, like the way for that is using a method from string class, and that method takes an integer, I think, or anything, I don't know, and it returns is a string object, or using this method, which is a method from object class, I think, or you just, like, this is a trick obviously, but if you append empty string that number, that what you get is a string. So these are three ways of doing that. So maybe I can take a screenshot of, maybe after each stream, maybe I can share what we have studied, like the notes, like that would be a great idea, right? The one liner. All right, like this is a term that I really liked. One liner. All right, thank you for that. Like, um, we have learned a lot today about casting and about like casting not being a conversion. So like maybe we should save it too. Now it is time for studying like solving this question using Floyd's cycle. Help me. So guys, I think I need to do like a maybe 18 hours long lead code session, like studying these kind of topics. Like I don't know why it is hard, but it is, it takes time. Like lead code takes time. Yes. Now let me make the 2 out of 10 because we studied a heap. Now we are continuing with oh, welcome Tarkus. How familiar you are with cycle detection in Linux? So like I am like I'm familiar with it because what you do in linked list is just using a fast pointer and a slow pointer, and you pray God that they will meet somewhere again. If you you have a slow pointer and then fast point. So let's say you have a cycle in your linked list, all right? And if you have a slow pointer that goes only by one, like head dot next, and if you have another one that goes like a head dot next, and at some point they will hit. So I think that's why you ask this, right, Carcass? I think it has something to do with happy number. But I thought in happy number it is 2 pointers. Like I don't know, maybe I just like a cycle detection. Floyd's run. Oh, linked list. Oh, I think we have the same logic here. Like, but how can we turn those numbers into a linked list? I guess for each number we calculate, like let's say we have 12 and we calculate let's say 5, and let's say we have 12 as a node in our linked list, and then we calculate 5 and we put it into our linked list, and then we calculate 25. That's one. That's wonderful, Carcus. Thank you. I thought I should use 2 pointers, and I didn't imagine any logical way of using 2 pointers for solving this question. But I wouldn't imagine like using linked list would help us solving this question. Um, and then for 25, 29, I guess. Yes. And then 81, 4, 85. Wonderful. So at some point, let's say we hit 5 again. So if we hit 5 again, we will point there. All right. Let's draw it better. So at some point you will. So all right. So I think what I should now is like creating a linked list and using slow and fast, and when they meet at the same point, I mean we should check if, I mean how can we check like maybe like a slow pointer and then fast pointer, and like we should recognize that like they are on the same node. How could we do that? like using the address of those nodes, or because I remember something like a detecting that they are on the same position. Don't don't actually need to build linked list, like okay, it's about visualizing all right, visualizing the problem as a linked list. All right, it is about visualizing, but um at least like we are creating some value at some address, and there you have a variable called next, and that next hold, let's say, an address of the next node, right? So basically we don't have like a something like this on in our memory, but each node has the knowledge of the address of the next node. What I wonder now is like how I can transform this problem into linked lists, and also how we detect if the slow pointer and the fast pointer are in the same address, on the same address, so that they meet, and so that we can say that we detect the uh, reoccurrence of the same result, and we say that we cannot find one using this number. um, maybe maybe we can outline this algorithm like a create or transform, like a create link a linked list using, let's say, like these powers, all right, and then apply slow pointer and fast pointer. So basically you detect the reoccurrence, and then if we detect reoccurrence, we return false, and if we find one, we return true. All right, and before you came, Carcus, we already have the proof that of um, like at some point we will have a cycle, all right, like, and the proof was like the numbers, imagine numbers between 1,000 and 9,999. If we apply this square rule, you have 1, and if we apply square rule here, I think it is 3 to 4. So there are, let's say 1,000 numbers here, and the numbers they will have like result is between them. So for sure there will be some reoccurrences. So we can generalize this idea, because I wonder, like, I thought that maybe there are no, like, there is no, like, there are some certain numbers that we apply this logic, like getting squares of their digits, all right, and we don't hit the reoccurrence at all. But I think it is not possible. So every number, like every integer, we will hit a cycle, either cycle or one. I mean, this is proved. So now our goal is like creating a linked list from the input. So let's say we have input integer, let's say 12, and like we should create a linked list, as you say, Carcus. So like I had a while loop, all right, like actually here what we have completed before you came, we have a while loop to calculate the getting squares. We need it here too, So I will call it like a this or at calculating the square. After calculating the square, maybe we should create a new node, let's call it new node for the sake of time. New node of let's say square. We create it and we should have maybe current node, all right, somewhere here, and we should make current nodes next equal to this square node, so that we basically do this. What if we don't think about fast and slow pointers as pointers and instead think about them as variables and look at their values? What if we don't think about fast and slow? So you are saying that instead of having a node, what we have is just a value. Like, are we gonna use linked list or not? I'm basically imagining a linked list, or I'm creating a node, like a linked list node, and connecting them, and then I will because in linked list there is a question for detecting cycle, and you asked this before, when you came. So, but now I guess you are trying something else. Building actual linked list, any linked data structure is rarely an optimization. They are all very slow data structures. Like they are slow, but if you use them with hash map, they can be very valuable. But standalone, if you have double linked list, there's a question LRU cache, all right, and here you have double linked lists, so you know the address of the next MPREV and you can build a cache with it, and it is quite fast because you know where to extract and where to insert immediately. But standalone linked list can be very slow because I don't imagine finding a number here. Let's say find 5. So to find the 5, you should iterate through all the array, and you could only let's say extract from tail, so it is not quite efficient. But I guess you are saying that don't build linked list, but instead think about them as variables and look at their values. So you are saying that I need variables, let's say variable 1, variable 2, and I should look at their values. Look at their values, you say. Let's say I have 5 and then 25, and then for 25 is 29, and then for 85. So let's say we have this. So what I'm trying to apply is Floyd's cycle detection, and it has something to do with linked list, but not that much, as T. Karkus says. I'm trying to find a way of solving this question using these variables, like a fast and slow, and only fast and slow I know is on linked lists. What if we don't think about fast and slow pointers as pointers? Because in linked list, pointers there is a slow pointer and then fast pointer. These are real pointers that points to address of those nodes, And basically you what you do is like a slow dot next, like you iterate, and you make fast by like a fast dot next dot next. So fast goes by 2 and slow goes by 1. So this is what I know. Like instead think about them as variables and look at their like think about them as variables. I don't know, man. I was gonna use this linked list approach, but you are saying that linked lists are slow. Yes, I mean they are not, uh, they say, suitable for every case. Most of the cases, they are not too handy. Basically, let me read it once more. Quick audit first. Since this is a distinct technique, which parts of Floyd's cycle detection do you already feel solid? To anchor it, one framing question. I want you to answer before you touch code. Floyd's run on linked list, yes. Slow pointer, fast pointer, yes. They meet inside the cycle. But happy numbers give you a number, not a linked list with yes. So like this doesn't give me, so I will create it by myself. So if doesn't give it, I will create it by myself. In this problem, what plays the role of the next node given you are standing on the number 82? What is 82 next? Like 82 next is 64 and 68. Yes, yes. It is 68. But what do you mean? Yes. Oh, I mean, what I would answer is 82 next is 64. Let me copy the message Karkus gave us in our notes. I think it is valuable. You secured 8, but did you fall? Oh, I'm sorry. Is 68. I gave it wrong. So now I'm trying to do what Karkus said. I will do it. Come on. The digit square, like a digit square sum. Like I like this term too. Let me paste it. Now Floyd's call. Next. Once for slow, twice for fast. Yes. Every step. That digit square engine you already wrote. Yes, the inner while loop is going to get reused repeatedly. Yes. So the clean move is to pull it out into its own helper method. Yeah. What would that helper signature look like? I mean, I don't see any reason like extracting this method and putting it to somewhere else. Like, I don't see any reason for extracting this method and put it somewhere else. I mean, we are like, I'm trying to understand how I can apply Floyd's cycle detection in this problem, and you are saying that I cannot use linked list. So, but I guess you are guiding me to there, but I don't see any valid reason to extract this part of the code, like the engine part. I guess it will be helpful, handy, but what is the reasoning behind it? All right. Like it says that use this or do that, but what is the reasoning behind that? All right, because I need to know the reasoning so that um, I can understand. So like we are now trying to remove the engine part, like inner for loop, and put it into its own helper method. But why? Fair challenge. The reasoning is specific to Floyd, not just good practice. Yes, like this is why I'm asking. In Floyd, every iteration you advance slow by one step and fast by two steps. A step is one run of your digit square engine. So per iteration you invoke that engine 3 times. So basically in float cycle detection, we're gonna need this inner while loop, so that it will be a great idea to have it into like in its own helper function. If the engine stays an inline, here's what your loop body becomes. So slow advances, fast advances, 2 steps. All right. 3 copies of the same loop. Yes. So the reason isn't methods are tidy. Yes. All right. So um, makes sense. Thank you. So it says that it should it needs its own method, like a using private keyword is a good choice over here. Let's call it void. I guess private void. Like I've seen the method, but I'm typing it down right now. Private void. And let's call it engine. Engine helper. And we will have bunch of while loops here, and those while loops will use, I don't know, integer. I don't know. Makes sense. Thank you. Continue. Like still, I don't imagine at all like a Floyd cycle detection. We have numbers, like Karkus said, using variables, 2 variables, variable 1 and variable 2. But like we have like linked list is the only thing I can see here. Like how we can make variable 1 go 1 step and variable 2 go 2 steps. And what is like before that, what is the meaning of moving forward? Like this is the thing that I need to understand. Like what is the meaning of moving toward, like forward? We calculate, let's say 5 is 25, like 5, 25, and then 29. So we calculate, like we use this square operation. If variable 1, oh, now I see. I think I see. So if we start variable 1 from 5, all right. So like I thought, like the reason why I couldn't come up with this idea before, like quick or before, is that like I have this while engine that calculates the squares, all right. I didn't imagine if I could use this engine like a more than one in our code, because in this solution we're gonna use this while loop a lot, all right. So let's imagine. So thank you, by the way, to Karkus. Thank you. So we have variable 1 here. We can assign it to 5, and then we can apply this engine to it once or more. Like now we need slow while and fast while. Like because when we give this variable to while, it will calculate all the iterations until it hit one, or like it doesn't have cycle detection in itself, right? Like, no, sorry. This while loop is just for calculating. Yes, this is engine. I confused with the outer for loop. This engine, like what it does is, come on, man. What it does is calculating the next one, like a next square, like. Did I save it? I guess yes. Digit square sum. So it calculates the next secure digit square sum. So we have variable one, and we can like give that to our let's call it engine. We can give it engine, give this variable to our engine. All right, and it can calculate the next the next value, the next digit square sum. Maybe we can, yes, so var1 next equals to engine var1. So our engine calculates the next the next digit square sum. So, and as Karkus said, we can have another variable, and then we can put this variable into our engine twice. How about that? How about that, man? We can put that variable into our engine once, like 1 and 2 again. So we are getting somewhere, all right? We are getting somewhere. I don't know where, but somewhere. We put var2, variable 2 twice, so that we and let's say they write or append their value into this. So var2 now holds, let's say var1 dot next, all right? Here we applied twice, and for variable 1 we only apply, we call our engine, our while loop, once. Amazing. And now what should we do? Now we should have some sort of cycle detection. Maybe we can have a while loop or something, and check if variable 1 equals variable 2. If it is, then it is cycle and return false. All right, because if they are saying we have we hit cycle, but how is it faster than using this approach? How is it faster than this? I run this engine multiple times. I guess the cost of using this is not that much, because in Floyd's cycle detection algorithm, we call this multiple times. Anyway, we can think of this later. We called our engines, they calculate the next next digit square sum. All right, it calculated the next digit square sum and the two next in var2. We compare them. If they are equal, we return false, and then the remaining part is same. I think. I mean, no, no, like it is not same. If they are same, then we return false. Like, but what if they are not same? If they are not same, then maybe, or maybe we check this, like if it is 1, then if it is, return true, or yes, I think this is the over, like like I didn't understand how, like if, like how Floyd's cycle detection is faster. Like this is the way. So let me write the engine calls. All right. Let's call like a function A. Let me copy this part and move it there. Like let's call our helper function func A, and we call this with variable 1, and it makes variable 1 to hold the next number. All right, and call I guess to apply this calculation twice, I think we can have another function called function B that applies twice this engine. All right, like this is my answer. So while true. All right, like I guess this is the Floyd wrong version, but let me describe this to AI. So now I have tried writing Floyd's solution. All right, I have two helper functions, one for calculating the next digit square sum. All right, and another helper function is calculating the two next digit square sum. Like in a while loop, while it is true, I call function A using variable 1 and function B using variable 2, and these functions will make these variables like a hold their next and two next, and then what I check is if those variables are same, like it's a cycle detection basically. Return, like if so, we return false. And then if variable 1, like another if statement, if variable equals to 1, then we return true. Like I hope it is correct, because it is a Karkus solution and suggestion. Thank you for we thank you to him. All right, if this is correct, and if this doesn't have like a crucial mistake, what I want to learn is how on earth this approach is faster than what we've just written. So now I just described the Floyd cycle detection algorithm to AI and asked how it is fast, like how it is fast, like how it is an optimized version, optimized solution for this problem. Let's see how AI will respond to that. Wonderful. At first, I didn't understand what Karkus said, but now I understood, because the engine part, like we use our engine part, like, and by engine I mean this while loop. All right, this while loop, like what it does is basically calculating the square sum. So we make use of this, and also we make use of the cycle detection by slow and fast pointer. Like at first I didn't understand uh, like this thing, all right, variable one dot next. So like only data structure I could come up with is like a linked list, but we don't need a linked list because here we use our engine, our while loop. While loop calculates this. So as soon as I realized that I can make use of this while loop and use it as an engine and calculate the next value, then I could understand Karkus uh, suggestion. Oh, I feel quite sad. There is a crucial mistake. Like this is sad. Good that you asked. It is in the order of your two. Huh. All right. All right. Let us think about it. Like I didn't think. I mean, I didn't think. I didn't think that the order would cause an issue here in our case because we calculate the next value, we calculate the two next value, and we check if they are equal to each other. Then there's a cycle here. There's a cycle here. And if the variable 1 is equal to 1, then we just found our answer. So I don't see any logical reason behind changing results on on the order. So it gave an example. So take n equals to 7. 7 is happy. All right, so we can reach 1 somewhere. Assume both pointers start at 7. Yes, your loop body in your stated order. Yes, 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 yes. Exactly, exactly. This is what I just written, stated. Here's a trace. Yes, fill in the last row. Iteration 1, slow is 49 and fast is this. They both hit. Oh, wonderful. Like this is the case that I wouldn't think of. Slow and fast pointers both hit 1 at the same time. Like there is the case where both slow and fast pointers are 1. Like I wouldn't think of this, man. At iteration 5, both pointers are sitting on 1. Now walk your two checks in your order. Which one fires first? And what does your method return? Now walk your two checks in your order. Which one fires first? I mean, like this one fires. And actually, I don't see the issue. Like, what is the issue? So they both hit 1. Like, they both hit 1, so we return false. Whereas, whereas we should return true. So when both they hit 1. All right, so all right, I totally get you. Thank you for pointing this issue, like this edge case. But can you give me the code? I will paste it into leetcode, and I want to see the cases that it passes, because for sure it will pass some cases, right? Like I didn't think of like this case. Maybe I should open leetcode 2. and paste the code that it will give. Let me arrange. Let's see. Ships. So leetcode AP number, I guess this is the one. We can copy the code here. Like this is our solution, right? This is the helper function that has our while loop that calculates the square sum. Yes. And it actually let me type it, all right, because so it is. Let me write it. We already know. So we need a private method, all right. I think it returns integer. Let's call it func. What it does is using a while loop while it is true. Like we had something like a result or something, yeah, result 0, and I guess it has a number too. What it does is adding like a first we should take the first digit, right, number, or call it helper, all right, and then we can change the name of it. Helper, we should get the digit. I think maybe we can create another integer here, digit, and then the first digits we can get is like a we can get this like number, take this one, so this is the first digit, and we should now I think get the square of it, and then paste it, like append the result. I think I just can copy it, alright. I already written down, so there is no need to type it again, right? So if the number is larger than 0, but I think we should initialize digit here with 0, and maybe result by 0. Like it calculates digit, find the first digit, takes square of it, appends result, divide number by 10. This seems legit to me. So the part, like the remaining part, is using this helper function and using like apply float cycle using var1 and var2, all right. So integer var1 is like a helper. If we give our input to helper, it will calculate the square sum. So this goes one by step, like this goes one step, and then let's create var2, and we should give it twice, like a all right, we call helper function twice, so that this went 2 steps. And now what? Now we should check if they are equal, all right. If they are equal, then cycle detected. then we should return false. Yes. And I think we need some sort of while loop or something over here. Yes. I guess I can type, thank you for thank you to carcass. All right. Um. Oh, I didn't log in. Let me copy the code. Let me log in first. Like I wanna see the cases that it pass and it fails. So if they are equal, then cycle detected. And if, like, my logic was this, all right, if variable 1 is equal to 1, then we return true. So I wanna see how many cases that it will pass, basically. Paste it over here and make it true, and let's run it. Let's run it and hope the best. Hope for best. Yes, compile error. Wonderful. Why? Where is the error here? If and then the method, I guess because of this one. Again compile error. Private illegal start of, like, maybe, like, this is the method. Let me copy it. So this is so there is a curly bracket issue here. Like, if this is while loop, this is for our method. Is this correct? Oh my god. Let's remove this. All right. Let's delete this too. Even delete this too. So this is if statements and this is if statement. And for while I need 1, and for is happy method I need 1 too, and for classes I need 1, and just above this I can type this method inside the class. Oh my god, what is wrong? Let's copy the code. All right, and maybe in the same session. I need you to fix the compile error here, and give me the code exactly as it is. Don't change anything. Like, this is class, yes. This is happy, yes. Private, I think maybe I should use static, but no, there is no change. Let's give it. I wonder what will happen. No, like private integer helper, yes. Like this doesn't return anything. While loop, it should return. No, it shouldn't return anything, so I should make it void. All right. No, actually, it should return an integer. Like we already written integer, so it returns integer, but we calculate, so I think it has missing return statement. I guess we should return results. And finally, we're gonna see time limit exceeded for 19. So take the code and like, can we paste it here and run? Maybe we can copy not the class but the methods. Maybe I just click on Python and Java again. This is the main method. Let's type the functions here and delete this part and call system out println, and maybe it's happy with 19, and let's put it into test. System out println, why we are getting an error? Non-static method. So I think we should like, we are in the same class, so even though we are in the same class, it is ridiculous that I cannot use, like, we should be able to use those methods. We are in the same class, man, but I don't understand it. Let's make it static, but we don't need to make this static. We are in the same class, but maybe it is about, like, it has something to do with the fact that we are in main class. Now it is compiling. Like, this shouldn't take this much because it is not running, it is compiling. Maybe I should just start quick run. Timeout after 30 seconds. Oh my god, what is the, like, I guess there is something wrong with our code. It is not just too slow. Like, what is the situation with 19? Maybe I should just, like, what is the example input again? No, it is just a simple input. Simple input, but I think for, fast, no, like, it should give answer correctly. Like, even the code I have here give me timeout. Guys, I'm sorry, I will look up the answer. So what is wrong with this code? I give 19 as an input and it gives me timeout. But I don't see anything bad, at least with 19, like with input of 19, all right? I know that if both variable 1 and variable 2 hits 1 at the same time, like, we have an edge case. But for input 19, we shouldn't have any an issue, right? But we are having an issue. So fix it. Like, I didn't think, like, we are giving 19 as an input and we are getting timeout, and the code, like, and also another issue is, like, why should I use static over here? The method itself is in the same class that it is called, so this shouldn't be a problem, but I will ask. So you are back in tutor mode, so let's trace, not dump. You are right, 19 has no both hit 1 edge case. The bug is different, so it says we have a bug. So it is the one I flagged. fill in this table. Helper 19. All right, let's fill it. If you say so. I mean, like for helper 19, it will give us 82, right? And variable 2 will calculate it again, like a 64, and yes, so this is it. And then in the like in the next, yes, so we are giving, like we are using helper function once for variable 1 and twice for variable 2. Yes, so all right, so this is the first iteration. And then in the next iteration, oh, like we don't give the calculated thing, like we give we give the same input again and again, so there is no like iteration or going forward or progress. There is no progress. We give the same number again and again. So like we give this one, right? But how else we can do this? Like we give the input, maybe we, like maybe integer input n, I mean equals to n, and then like a maybe call it imp, all right? And we can give this, actually we can make use of the same n, right? Like after this checking, we should update n with what? I mean, they should progress. Maybe I should give the new version, like a maybe, I don't know, int var, let's say x1, all right? Terrible variable names, var x2. Like what I'm gonna do with them is like a giving this one, all right, and this one, and update them at the end of the for loop. Like this is what I need to do, right? So var x1 now is var 1, and var x2 is equal to var 2. So we updated them now. Like this is, now it is better. We call the helper function, we calculate the next square sum, we calculate the next square sum, we compare and we check the cycle detection. And now for us to progress, we should update those values. So now I guess I can copy the code we have here. I mean, copy the code we have here and paste it into leetcode, and hope for maybe only his happy method, the content of his happy method. Seems legit. Wonderful. And we are getting wrong answer for 19. Why? We are returning false. For 19, do we have the edge case? Like let me ask you this. Now I have updated my code like this, and I wonder if 19 has the edge case or not. I mean, both slow pointer and fast pointer hits one at the same time. Like, does it have this or not? And also I changed the code, by the way, so that because previously we weren't progressing, now we are progressing because we are updating. Like in each iteration in while loop, we update our variables. I will do it, Carcus. I will do it. Without it, like without completing, I won't take a break. But we are getting closer. We are getting closer. At least I understood the variable approach of using cycle detection, because only approach I know was linked list. Progression fix is correct. Yes. Carry forward now. Yes. Slow advances once, to fast twice. That part solid. Now your actual question does not. I guess yes. Yes. 19. So now let me run the code again. Now it gives false, but like, what is the input? No, like the input is here, and if we, let's say, give 20 instead, what would happen? It is false again. Like do we have, can you give me some other example input so that I can check and see my partially correct code is working correctly for some of the cases, not all of the cases, but some of the cases. Like, before solving this edge case issue, I wanna see it is working for some cases. Like, I wanna have example cases that I can test our code. All right, this is all I want. And then I will focus on the edge case where, like, slow and fast pointer can one at the same time. So like, actually we can solve this issue by moving this part above the cycle detection. That's all, guys. That is as it is, right? 19, run the code, and true. Wonderful, guys. We've done it. Finally. We've done it, bro. We've done it. Home. That is interesting. We have done it. So I guess if I copy this part and give it to leetcode again, then we're gonna see it working. It is working. Oh my god, I can take a break now, I think. Yes, except wonderful. Wonderful. That's amazing, guys. We have solved this happy number question using Floyd's cycle detection, and the good part with this is, like, designing the chain by using these two variables, because only chaining I know was linked lists. So each time we call this helper function, we get the next square sum up. All right, so let me use the correct term for that. Digit square sum. All right, digit square sum. So after calling this helper function, we get next digit square sum, and calling it twice, we get next digit square sum. like we basically visualize, like we basically animate or visualize this chaining, like chaining thing. All right, like a linked list. Wonderful, wonderful. Thank you for Carcus for guiding us today. Uh, that was an amazing feeling to solve um, this problem. The Carcus. Yes. Thank you for the guidance. I solved it using Floyd's cycle detection, and it is not even a link list. Wonderful. Now I will take a break. Let me check the wonderful. So guys, now I will take a break now. Like um, when I come back, I will continue with like I will continue taking notes here obviously, and then after that I will continue with set matrix zeros, like continue with this problem because I want to complete all of these problems here. All right. Um, so let me click on the break. So I guess we can set it like a 15 or 20 minutes. I think 20 minutes is good. We earn it. Where is my take a break thing? Right, let's make it 20. Yes. So see you after 20 minutes. All right. Bye bye. Welcome back, guys. Now we are back. Oh, I had my dinner. I feel more energetic right now. I can handle 100 more questions, leetcode questions. All right. Now let me, decrease the sound a little bit more. So, where were we? So, um, I think we have solved the question. All right. And now our next question is set. I think let me start with the you know like handling like a taking notes of that question first, like a happy number. We have like a completed um like this is the code. Let me paste it, and this is the helper method. Wonderful. Like I can add some notes more later. Now it is time for set matrix zeros. So let me update the title. Floyd's algo. Let's make it 3 and not happy number, but set matrix zeros. Set label, and maybe we can change the color as well. Let's make it blue. All right, wonderful. So maybe let's start. Let me also start this Pomodoro. And now our goal is to study this problem. What is it? So now activate tutor mode 2. I wanna study this question. I don't know its topic, like it can be like a greedy problem or something, I don't know. Like activate that skill and let's study this algorithm. I wanna learn it. So, and also I thought like now I think we also should create the necessary files for this problem, I think, but we already have, like in Java, I think we have, all right, yeah, yes, this Floyd cycle detection approach, but we don't have our like a first approach, like no, like this is the first approach we have. Yes, while true, we add the result to our set, and if it returns false, then we return false. So this is our first approach, and I think the remaining part is like for happy number is amazing. I almost understood everything, all right. But the remaining question I have is that how the cycle detection method is faster than the first our first approach. So yes, so let's open it. Oh my god, did we like there it is. Let me copy it and paste it again. Yes, let's study this set matrix zeros question. I don't know what it is, but let us solve it and understand it. So maybe I can update the topic solving leetcode problem. Wonderful. No matrix concepts in the index yet. This is fresh territory. Yes, like I haven't studied before. Let me start. Before we start, which parts of this problem do you already feel confident? Like I don't know the question. Like uh uh sorry, close that one. Lead code. Like what was the question name? Set matrix zeros. Set matrix zeros. So let's open the question first and take a screenshot and then paste the question. So the question is this. Let me read it in our, notes so that I can annotate a little bit. Wonderful, wonderful. So I guess this has something to do with matrix, and I don't know matrix. So given this integer matrix, if an element is 0, set its entire row. Like I remember this question. You must do it in place. So like I have done this before, I have solved this before, but I don't remember like a fully. But like there is a 0, like there is 0 here, and what we do is like making the whole column and the whole row zeros. So I think this shouldn't be that hard. This is input, so array of arrays. So I guess we can make use of nested for loops over here, and like first loop can iterate through this part, and then the j will give us the element itself, like in each. All right, so like our goal is making, so like maybe we can call, like maybe we should call like these for loops variables, not I and j, but row and column. And here we have row and columns. All right. Like maybe we should have like a set for columns and set for rows, like each row. But these uses sets like a space very harshly. Maybe we shouldn't do that. But here, like inside here, we have like a row and column, but we should have sets. And like how would you first of all, let's focus on making the column. Let's say we are here. How would you do, like how would you set these values to 0? Like its column value. Let's say column is equal to 1. Wonderful. Let's say column is 1, and you should find all the elements where like their column value is 1. How would you do that? Like I don't know, and let's talk about this in our AI chat. For example, do you already know why? Oh, welcome, Tar. Welcome in. How is it going? How is it going? How are ya? I'm studying leetcode, algorithm questions. Do you already know why the naive zero out is used to can approach breaks? To be honest, first of all, like I thought that, do I know like a setting all the elements, like let's say we have an element on column 1, like whose value is 1, all right, and let's say we want to set all the in the same column elements. We want to make them we want to set them to 0. All right. First of all, I want to learn this. All right, because I should be able to do this, and then I should realize that 0 out, as you see, can is not a optimal approach. All right. First of all, we should focus on this because I'm not quite familiar with it. Went to take a final test today, so it is wow, wonderful. I feel good for you because completing the exam term is good because the term finishes and then the holiday starts, right? For a couple of months you will have a rest, right? Awesome. This hurts my brain. God help you with that. Thank you. Like it hurts my brain too. All right. But I guess since I spent lots of time with these codes, it is kind of easier. But still, I push my limits, to be honest. Oh no, still you have 4 more to go. All right, all right. At least there is less amount of exams. All right. I wish you luck in your exams. I mean, maybe even I can count exams as harder than coding, because their stress level is just something else. Because here, I can earn some money from these, all right? But while you are studying in uni, you don't earn some money. Good. That's the right place to start. Master the mechanical move first. I mean, yes, mechanical. So let me save it too. I really like this term too. 0 out its whole row and its whole column. So my focus is being able to do this, all right? So let's build just that helper. Given one cell, 0 out its whole row and whole column. Everything else builds on that. Yes. If I hand you this matrix and a position, yes, and I say 0 out everything in that row and everything in that column, how many loops do you need? And what does each one walk over? So it didn't give me anything helpful. I already know it. But it says that what kind of loop would I need? So I know the column value. So let's see, this is 0 0, right? And here is 0 1, and here is 0 2, 1 0 1 1, 1 2, and 2 0, 2 1, 2 2. So we should make 0 1, 1 1, and 2 1, and we should set their value to 0. So maybe I need a loop, maybe a for loop, since the column is same here. Maybe I just need a row for loop, and then since I already know a column value, which is 1, and we can just iterate through all the rows, and let's say row comma 1, and we can set this to 0. I think this is the all right. So this was the thing that I was looking for. This is what I was looking for. So we got this part right. So how about the row wise? So I think we can type the rows 1 0 1 1 and 1 2. So row is same and columns is changing. So for like we can make use of. I'm having a coding exam on paper exams, and coding similar to one paid, the other isn't. Oh, but one paid and the other isn't. So you are earning some money from coding. That's wonderful. So what is your major, by the way? Like, do you study computer science? Tar? And you were in your first year, right? No. You said uh, engineer, technical engineer, right? But I didn't think that you are having coding lessons, coding lectures. So you know coding too, right? So for the next like for loop, um, the rows are the same and the columns. So columns can start from 0 and we have row. So we have row equals to 1 and the column, and then we should set this to 0. So like here we see setting columns to 0. Yeah, technical engineering. Setting column to 0, and sorry for the bad. No, I guess your English is quite good. C++. Wow, wonderful. You teach me. You should teach me C++, man. Because uh, Unreal Engine, like in this game development environment, they use C++, and like I have a few games that I have built on Unity, and it uses C sharp, which is quite similar to Java. But I always wanted to learn C++. Next year, either Python or MATLAB. Wonderful. Like Python is used for like in everywhere. So I'm also learning Python, by the way, because there are some job openings in their requirements. They say Python, and in these streams, I will be developing some Python projects as well. Setting rows, like here we are setting rows. So let me take a screenshot of it too and paste it over here. And let's answer what AI asked us. So I think for setting, like let's say setting the row, like we need a for loop, all right? And since we know the row, like which let's say it is 1, we should iterate over columns in that for loop. And for column, we should iterate rows starting from 0 to the end of the rows, and we should use the column value that we have. Let's say 2 for loops, we can handle this. Like if we can set, like if we can zero out. Wait a second, my internet dying. Why is your internet is dying every time? In Unreal Engine, they use C++, and I wanna learn plus too. C++ is always, was always in my list. I also learned Python in these streams. Wonderful. Exactly right. Row is fixed. Sweep the columns, column is fixed. Sweep the rows, 2 loops. Independent, yes. Write the helper, signature is up to you. Something like, all right. So like it wants us to create a signature. All right, what kind of signature we can build? So maybe a public method void that takes like a, maybe let's call it method, and like a double integer it takes, like a, this is our matrix, and I don't see anything it needs. So like a for loop, like we already written this, right? Go ahead and fill. So for the first for loop, like there is a for loop and its iterator is row, and row is smaller than length, and it starts from 0 up until the length, and we already have the c like a column value. Let's say it is 1. Like instead of describing, let's just write it down. All right, guys, let me remove these parts and copy this part and type the code. So like we already know the row and column over here, so it is good for us. All right, we just can create a for loop over here. Start, let's say row starting from 0 up until to the point of matrix dot length, I think, and increase the row, and we know the column value, so we should set it 0. So using matrix, like we already have the matrix. All right, so like first one is row, the second one is column, and we should use this one, all right, as column value, like the value we get from parameters, and we should set it 0. It says fixed row, but I think we should remove this to like under this loop. All right, so here we need another for loop. Let me type it. So this will use not row but column. Columns will change, and column will be matrix dot 0, like you take the first array and take its length, and it should be smaller. I mean, like already smaller, but we should increase it. This is column for our for loop, and then we should like, now we know the row. All right, now the columns change. So columns changing, we setting the row 0. Wonderful, and that's it for the essential, like a foundational part. Like I said AI that I don't know how I can set rows and columns to 0, and now it showed me how I can do that. It is easier than I expected. Like we use for loops, and we imagine ourselves like we already know the current row and column value. Let's say we have like a, imagine we have, like we know our position. All right, let's say we are here, so like we have its row and column value, and using this row and column value here, we set it. Okay, I am back. That's a nice info to know. Yeah, this, like we can do maybe study stations for C++, like after Python, but of course my next goal is learning Python. After Python I can learn new languages. It says go ahead and fill, and we've done it. So So now we know how to set like rows and columns to 0, which is wonderful. Let's paste it. I guess now I understood how to set uh, the current row and current column to 0. This is wonderful. So what is the next step here? Thought it is only C sharp. What is only C sharp? I mean, Unity uses C sharp and Unreal Engine uses C++. That's correct and clean. Yes, 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 yes. Now the real problem. Naive idea. Scan the whole matrix, and every time you hit a 0, like scan the whole matrix every time you hit a 0. Yes, so like our first approach, like a naive approach, uses like every time we hit a 0, like we do this. All right, like for example, for this dot, we again set the row 0 and the column 0. We should obviously optimize it. Yeah, like Unity uses C sharp and Unreal Engine uses C++, so like it is good for you. Like I see C++ as a language of, cool guys. Predict before you run it. Take this matrix and like currently what we need to do is like optimizing it. Instead of setting this row to 0 again, because we already did, maybe we make use of some sort of flag or something indicating that that column, like that row, is already set to 0. Maybe some sort of flag, I don't know. Change of plans. I'm making a game in summer break. Wonderful. Like that will be an amazing idea. Like I created a few games and it really helps you learn object-oriented programming principles. Like it really helps. I guess for me at least it is the only effective way of learning object-oriented programming principles. Because when you try to learn it from textbooks, it is not helpful at all. Predict before you run it. Take this matrix and walk it left to right, top to bottom, left to right, and top to bottom. All right, so when we hit this, so another issue emerges, guys. Another issue emerges after making what the question asks us, like this will be 0, this will be 0, like so when you iterate one more, like when we iterate forward, you'll see another 0. So like the issue is not only optimizing, like it is not only about optimization, it's also about making the code running correctly. All right, run correctly. What does matrix look like when you are done? Like I guess what you are trying to point out is that like we have a 0 in the middle, and after we apply like a 0 out the row and column, in the next iteration we're gonna, let's say, process another place, and that place is zeroed, like a 0 outed. So again we will we'll have to do it again. I guess it is not a correct way, right? Like our naive approach was iterating through the matrix, and each time when we hit a 0, each time when we hit a 0, we zero out the row and column. But if we do that, like it may be a problem because we lose our initial state. I guess it is the issue, like, because at first I thought that after you say, like, I thought that we need to do some optimization, but I guess it is more important than even optimization. It is about making the problem, like making the solution correct. So guys, so we have an issue, right? See you later. Wait, Matrix. Thank you. Thank you, Tar, for stopping by. Stopping by. Thank you. Um, what does the matrix look like? Yes, so press enter and send the message and expect the answer. Yeah, exactly. You nailed it. It is the correctness. Yes, it is the correctness. Correctness problem. Before it's an optimization problem. The zeros you write look identical to the zeros that were originally there. Like this is the problem. Yes, this is the exact problem. This is the exact problem. So the core question becomes, how do you tell original zero apart? Like, how do you tell original zero apart from zero I just wrote? So, like, wonderful. So it is Java, and maybe we can create a leetcode section. So, guys, I will plan to share the notes that I take during the stream, so that later you can review. So this is the real problem. So we need to distinguish different type of zeros, right? Like the original zero and the zero I just wrote. So what is the simplest idea you have to avoid the chain reaction? Like, all right, like the chain reaction. Wonderful. Like, I like this term as well. Let me paste it to my English session. Activate the navigation. This is Java and leetcode. So I guess we also need to make the leetcode heading. It is now better. So now our goal is to avoid this chaining react. Don't worry about saving memory. So just like, maybe like the first thing that I come up with is like maybe using, I don't know, maybe another number, like maybe -1 or something instead of 0, so that we can have -1, a 0, so that we can distinguish original zeros. Like, is it the correct way? Yes. Like, I don't have anything in mind currently, so like we need to distinguish. Like, like we have a matrix, all right? We have original zeros along the way somewhere, and what we need to do is like a changing, like making the row and the column that it is in to zero out it. All of them should be 0, right? But the problem with that is when you find, you know, like you make this row and this column 0, but the next item you're gonna process is this one. So this is again 0 because you zeroed out, right? So there is no distinction between the original one, all right? There is no distinction with original one versus, let's say, brand new. Brand new, let me call it that way. And let's see. Good instinct. That's the sentinel marker. Oh my god, that's another good concept. Like I mean, word I hear, word I read. The problem says cell values can be any integer, negatives included. So I hand you this matrix. You decide to mark cells with -1. What goes wrong? So um, it is asking another wonderful question, guys. What do you say? You decide to mark cells with -1. What goes wrong? Like, like here again, I lose like I'm. It is possible for us to lose the original zeros again because we overwrite. Like the question asks us to handle this in place, uh, but when we do this in place, we lose because the action we take overrides the future. So we should find the solution for that. So like this, like the part where this question is interesting is, let me write it down, guys. The part where this quest is interesting is the brute force brute force approach overrides future, so we can't do it in place. So we need to find a way to overcome this issue, guys, because we are writing the future. We are changing our input array in place, and we are iterating one by one. So close. But look more precisely. Look at the top middle cell. It's already -1 in the original input. So when your second pass sees a -1, can it tell the difference between a cell I marked and a cell that was burned? Of course, no. Like we cannot distinguish between the -1 we put and the -1 that is already there. We can't distinguish. We can't distinguish. But also this is the problem too. But the thing I said earlier is also a problem, right? We override, like we change our input array. Like we iterate through left to right, top to bottom, and when we change the value, like let's say we set the value to 0, and then when we find that value again, we don't, like we can't distinguish if it was already a 0 or we uh we are the one who makes it 0. So I guess the problem is distinguishing. The problem is distinguishing the original one and the one we just created. So this is the issue. Like this is the issue we need to solve in this problem. Right, both are real, two separate problems. Writing 0 directly, chain reaction. Can't tell my 0 from original 0. Yes, can't tell my 0 from original 0. So let me save this too. Picking any magic number, like I thought that maybe we can make use of a magic number like a -1 and solve it, but it's still like we still cannot distinguish. Even we use -1, actually -1 should solve it, right? -1 should solve it, but it says that it collides with legal data. Can't tell my mark from a real -1. I guess we still have the same problem. Both have the same root cause. You are trying to store bookkeep like a bookkeeping. These row and columns needs clearing inside the data cells, but every cell is already meaningful data. Yes. So there is no safe place to write inside the matrix. Yes. So like I mean, it will say creating another array or like a copy. Is it? Don't try your bookkeeping into matrix at all. Keep it outside. But how can I? First pass scans the whole matrix and just records which rows and which columns contain a zero, somewhere separate. Second pass, all right. I guess the solution is using like I mean, in two passes. Because like I was trying to solve this in one pass, but you don't need to do that. First part, like first pass is discovering, and the second one is doing. Save this. Second pass uses those records to clear. What data structure would you use to record? I mean, would you use to record which rows and need zeroing? I would use set because I don't need to store every answer. Like those answers can be the same. Like can be same row. Same row should occur in different iterations. So saving them, like saving it once, is quite enough. And which columns and so I would use set data structure because there's no need to store each occurrences of the same row and the same column. Um, but in that case, let's say if we have like a hundred times a hundred uh, matrix, then we should have like 200 headsets, right? Is it a good way? I mean, we are sacrificing our space because let's say the input is 1,000 to 1,000, then we should store 2,000 headsets. One correction on the wording, it is not 200 sets, it is 2 sets total. One set of integer for rows. All right. We like I thought. Oh my god. I mean, I thought that. Like I thought that we would need like a, let's say, 4 to 4 matrix. All right. I thought that like this is first column. All right. The second, the third, the fourth. All right. 0, 1, 2, 3. So I thought that I need to save each, I mean, like this is a column, this is another column, this is another column, and this is another column. So there are 4 different columns. But instead it says like I thought that maybe we should use 4 sets, but instead we should use only one set. Only one set. And that set will store, let's say like 0, 1, or let's say 3, like the column IDs. Let's say column IDs. That's all right. Like why did I think like that? Why did I think I need for I think there was another there was another question, all right? And in that question, um, I guess we had this number of sets or hash maps, I don't know. But yes, in this case, in this problem, having only one set is quite enough. Like once having one set for columns and having one set for rows is quite enough. That's wonderful. So um, in the worst case, they hold up to 200 entries between them, not 200 sets. Big difference. Yes, this is quite a big difference. And yes, it's a good way. Two sets give you extra space instead. Two sets give you m plus n extra space instead of yes. All right. So write it. Two passes. Mhm. I guess the AI is already like written the code. There is for loop starting from R. We increase the R and this column. Just scanning like we already written this part. Didn't we already write that part? I mean, we already have this, so it is kind of, slightly different version of it. So like the answer is slightly different version of this, right? So like having um, like a for loop, two independent for loops, and what we need instead, like instead of setting that address to 0, what we need is um, storing that column, I think. But instead, like instead of two for loops, what we need now is just a single for loop. Let me copy this part. I mean, copy that part, paste it here. Instead, like what we need is, oh, I cannot type it, man. Just stop it. Like what I need is like a single for loop, all right? Single for loop. What we need is like using a single for loop. Um, Actually, we cannot handle with single for loop, but instead we should use two nested for loops so that we iterate through each position in our matrix. And as we find a 0, like if 0, then what should we do is saving that address. So save that address of our RC. So we should save this address, and like this is the first pass, like a first pass. Like it should be something like that, all right? How about this one? What do you say about this one? Nested for loops, we iterate through the matrix and find the indices, like locations, which is equal to 0. Welcome, guys. I'm currently working on matrix zeros leetcode problem. And after that, I will study this problem. Right shape, nested loops over every cell. Yes, that is pass one. Now the key question, and this is the heart of it. When you find a zero at this address, what exactly do you record? Like I would record like this. I would record like a this tuple, like a this as a tuple, right? But which data structures can we use for it? What exactly do you record? You said saved address. Yes, like I literally said it. But do you actually need the pair? Like like my first question is how can we store this? Like which data structures do we need for that? Maybe key value, I don't know, like a hash map or something. And then the second one is think about the pass two needs to know. Like in passing, like this is the pass one, this was the pass one. We get the addresses of those of those zeros, all right? Like this was the pass one, and in pass two, what we need is like actually we don't need to store the addresses of those row and columns, but instead we should have and hash, like we already talked about this, but now it makes sense. We should have hash set, all right, and we should like maybe two hash sets, all right, two hash sets, and one is for columns, let's say for rows, and the second one is for holding the other like addresses of columns. But this is what we need. So I guess we just need like a two hash sets. Like in the first pass, instead of storing the addresses of like these row and columns like as a tuple, what we need is like populating these two hash sets, one for rows and one for columns. All right, this is what we need. Let's paste it here, and maybe we can, like if it is zero, like we don't need to save the address, but instead we should have a set of integer rows, and here's the implementation part, hash set, and it is generic. Wonderful. So this is for rows and this is for columns. Wonderful, wonderful, wonderful. So instead of storing the addresses of those row and columns, we are gonna fill, for example, that row with the address of that row. Wonderful. And like I mean rows, not row, and columns with C, right? So this is what we should do instead of storing. So like another question is, how can we store this tuple? This is another question that I don't know. I don't have the answer of it. But like this is a good way, because at first I thought that we should store the addresses like a row and columns together. Wonderful. Exactly. When you see a zero, yes, 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 you collapse the 2D position into two independent 1D, like one dimensional facts. You collapse the 2D position into two independent facts. Let's save it into our notes too, guys. I like this term. Write pass one fully now with the two sets. Declare the test, fill the necessary. So like this is what we have. I mean, this is the first pass method we have. Let's paste it. If you guys have any question, you can ask me, and I'll try my best answering. The add call are right. Fill in those empty loop headers. You know how R over rows and C over columns. But here's a real design question, not a typo. You declare rows and columns inside yes. So just merge both passes into a method then. Yeah, of course. So of course we initialize these test sets inside the method, so there is no way we can share them outside of this method. That's the clean fix. One method, both passes share the same scope. No reason to split it. Write the whole thing. All right. I think, guys, I will take a break now. It's been almost 5 hours, and I will go for a walk. And when I come back, I will continue. Like, let's see the full answer. All right. Give me the whole code. I'm tired. So I will take a walk. Like, I will go for a walk, and then when I come back, most probably, or maybe tomorrow, I will do it. I have a hackathon. Maybe tomorrow we can do like a 8 hours long stream for that hackathon. Um, yeah, maybe in the morning we can do one quick lead code session, and then we can make a maybe I don't know, maybe 6 hours long stream for that hackathon. Yeah. So I will announce that in the schedule part. All right. The single zero clears its whole row and the column. No chain reaction. Two design notes on what we wrote. Pass 2 scans every cell and checks. I don't know, guys. I feel quite tired. I think, you know, it is a good time to take a break now. I have little brain cells to comprehend this. I guess we are in pass 2, and like in pass 1 we collected which columns and which rows that we should um, zero out, and the in pass 2 what we are gonna do is actually like a zeroing those rows and columns basically. So pass 2 is quite easy. Sequence every cells and check if rows contains R, columns contains C, instead of calling zero out cross per doomed cell. Why? If you called zero out cross once per recorded zero, overlapping, yes. So or sign is the whole trick of pass 2. I think we have a trick in pass 2 too. A cell dies if either its row or its column doomed. The time. So what we do attempt that optimization? I think it has already created uh, that file. Let me check the code. So like this is first pass, guys. We have a for loop over here. We have another like a nested for loops, and when we find a zero, we basically add it into our rows hash like set and column set. So this is first pass, and then in the second one, again we iterate through the two-dimensional array. But while doing that, we also um, like this is the this is the core part. If rows contains row or columns or maybe both of them, we set that index. So what we are doing is basically, again we iterate through through this 2D array, all right? And like we have a for loop for that, and we check if it's either R or C value. We have two headsets, like a hash set 1 and hash set 2, all right? And we check like maybe rows or columns. Maybe I should call them, rows and columns sets. In first pass, we know in rows set, let's say we have like a 0, 2, and 4, all right? And like for example, we should zero out this column and then 2, and let's remove 4 because we don't have 4. So we have this information, and let's say in columns we have 1, all right? So, or even make it with red. So we should zero out this row. Like we have this information. Now, by looking at these H sets, what we are doing is, again we have a nested for loops. So we basically iterate through each position and get their R and C values and check the H set to see if it has that row value. If it has, we just zero out that, all right? So our logic doesn't work like a happening in real world, all right? Because in real world, let's say if you know which column or which row to zero out, you can if you for rows, if you have let's say 1 and 3, you would zero out that row and that row, all right? Because even in pass 2 you would do that, you would definitely do that. But here what we do is different than this. Instead of zeroing out the column and the row immediately, what we do instead is coloring, zeroing out this one, all right? Like it has its own location, it has its own coordinate, coordinate R and C, and you decide whether you should color this or not by checking its values, whether if they are they exist in the hash set, related hash set, like a row hash set, like a rows, or columns hash set. You check, you have a value, you have a coordinate, all right? You have this information, and you check if that imagine rows as a list, all right? Let's say 1 and 3 and columns as, let's say, 2. All right, and the current row and column is, if it, let's say, if it's 0. All right, it is a 0. Now what we check is like a, is 0 like a, this row is like a in rows set? No. Or if the column is in column set? No. So we don't do that. But if any of them, let's say we have R and C, and let's say R value, let's say 1, and the column value is 2. All right, so we compare, like we check row with row, and row value exists in row set. So we immediately let's say 1 2, right? So 1 2, let me draw it. So row 1, so this row, and so this one. So what we do is just coloring this one. So we go one by one instead of, let's say, coloring all the row. What we do is just doing this part. All right, going one by one. All right, so this is like knowing language. All right, like a translation, translation, right? So thank you for joining me today. We have completed 4 lead code problems. I will take a break and I will go for a walk now. And then maybe I can start another stream for maybe this time Python. I wanna study some Python until I sleep. So it was amazing to study with you guys. Thank you for stopping by. I wish you a nice evening, since it is evening to here. I will take a break now, and maybe I can start another stream in a few hours. All right? Take care. I love you guys, and see you next time. Bye bye.